So this is the question. So transpose of matrix. So we have we have read the problem statement. We have n cross n matrix, and we have to exchange. We have to find a transpose. So I'm going to talk about this particular question, which is the problem of the day for in Geeks for Geek. This transpose of a matrix. Transpose of a matrix. So what the question states is, like, if you are given one matrix 1 2 3 4, suppose, then you have to make its transpose and it will become 1 2 3 4. So you can clearly see that these elements, the rows and the columns are like exchanged. Okay, so this okay, so this over here becomes this, and this row over here becomes this. So this row becomes this column, and this row again becomes this column. Okay, now we have given the constraint that we have to solve this problem in time complexity as big O of n square. So that clearly means that we have to traverse this matrix, and also the expected auxiliary space is big O of 1. Auxiliary space is big O of 1. That clearly means that we do not have to use any uh, like we do not have to use any uh, array vector or anything that takes any big of n, or any grid that takes or any other matrix that takes big of n square. So we don't have to take any other data structure. So um, this is the thing. So let's take one more example. Suppose we have given n is equal to 4. So this is a 4 cross 4 matrix, that is 1 1 1 1 2 2 2 2 3 3 3 3 and 4 4 4 4. So to solve this one, what will be the transpose of this matrix? This is a 4 cross 4 matrix, so the transpose would be 1 1 1 1 2 2 2 2 3 3 3 3 and 4 4 4 4. So this would be the transpose. So we can clearly see that this row over here becomes column. This row, so suppose this is 0 1 2 3 and 0 1 2 3. So this row 0 becomes column 0, row 1 becomes column 1. Similarly, row 2 and row 3 becomes column 2 and column 3 respectively. So this is the thing. So let's think about the naive solution. So the naive solution would be to traverse the matrix. The naive solution would be, suppose this is the matrix 1 2 3 4. We have to make 1 2 3 4. Suppose this is the matrix. So what we can do, we can traverse the matrix fully. 1 2 3 4 in this manner, and we will exchange the I ij of the matrix with ji. We will just swap it, ij with ji. So if we swap 1 1 1, so this is 1 1 0 1 0 1. So if we swap 0 0 with 0 0, it would be 1 only. If we swap 0 1, this guy is over here 0 1 with 1 0, it would be uh, suppose this thing 3 2. Now we will go for this. Now we can clearly see that this has already been swapped. So what we can do, we can all maintain one grid which can put all the values. Suppose this is a grid, visited grid. So what we are doing in visited grid, we are maintaining a visited grid of the same size as of matrix. And what we are doing, we are storing 1 in that grid if we have touched those positions. And if it is not 1, then only we are going to change it. So for 3 it becomes 1, for 4 it is not 1, it is already 0. So we will exchange 1 1 with 1 1, so it becomes 4 only. So we can clearly see that the diagonal elements do not change. Diagonal elements do not change. I mean, they are swapped with themselves only. Okay, they are swapped with themselves only. So this naive solution clearly takes big of n square time complexity as we are traversing the array, and also it takes big of n square auxiliary space because we are maintaining a visited grid of same size as of uh, the the given matrix, time complexity and auxiliary space. But this is a naive solution. So what we are doing in naive solution, we are just maintaining a visited grid. We are traversing the array for all the elements. We are checking if it has not been visited, then we are swapping the ith and jth row column with jth and ith row column, and we are filling the visited grid 1 if we have touched those locations, and if we haven't touched the location, we are going to swap. If we have touched the location, that is it, if it is marked with 1, then we are not going to swap. So this was the naive solution. So let me just write the code for you. So for the naive solution, we can do for int I equal to 0, I less than your size of the matrix I plus plus, for int j equal to 0, j less than n, j plus plus, and we are going to check if not visited I j, if not visited I j, and I is not equal to j. So we are what we are doing over here, if not visited ij means that it has not been visited, so it is actually 1 0 0, so it becomes 1. And I is not equal to j, what it signifies that it is a diagonal element, so we do not have to swap the diagonal elements. But we can do this thing also. If it is not visited, and if it has not been visited, then we will, what we will do, we will swap the arrayth ith element with the jth element, and we will mark visited of I j to be 1 and visited of j I to be 1. So both are touched. Okay, so both are touched, so we have marked the visited one, and in this manner we are swapping it, and this is the whole code. And let's create the visited array. So to create this visited array, what we will do, we will create a visited array of n cross n size, and mark all its elements as 0. Mark all its elements as 0, or you can use a vector also. So for using a vector, we can clearly do vector of vector int. This is a 2D vector of PEC of size n, vector int n 0. So this will create a n cross n size vector and fill all its element to be 0, and we will continue in this manner, and we will return the array. So this is clearly taking big of n square time complexity and big of n square auxiliary space. Now this was the naive solution. Now let's talk about the efficient solution. Efficient approach. What would be the efficient approach? So the efficient approach would be to, like, it's given 1 2 3 4 5 6 7 8 9. So we can clearly see that the diagonal elements remain uh, intact, they are not swapped. So what we can do, we can we can exchange. So suppose this is 1, so we are exchange swapping it with 1 and 1 only. 2, we are swapping 2 with 4, so it is 4 and it is 2. 3, so 3 is swapped with 7, 3, because this is 0 1 2 and 0 1 2, so it is swapped with 0 2 is swapped with 2 0, so it is 3, and this is 3, this becomes 7. Okay, so in this way it is swapped. Now when we are like if we move in this fashion, from if we are following this particular loop only, then what will happen? If we touch 4, then we will eventually exchange 1 0 with 1 1, so it will like exchange 4 with 1 0 with 0 1, so 1 0 with 0 1, so 0 1 is this, so these both elements will be swapped, but it would not be the answer. Okay, so the answer, the transpose would be 1 2 3 4 5 6 7 8 9. Okay, so it will be exchanged 1 2 3 4 5 6 and 7 8 9. Okay, so what I was saying, that if we move in this particular order, then this 2 and 4 will be swapped, so and we do not want it because it's not the right answer. But if we traverse over here, so like if we traverse in this fashion, let me show you, we traverse in this fashion. So let's swap 1 1 with 1 1, so it is 5. Let's swap 1 2 with 2 1, so 1 2 swapped with 2 1 would be 6 8, and it would be 6 over here, and 9 9 swapped with 9 9. So we can clearly see that the answer to this particular question is this is the answer, and we are not using any extra auxiliary space. So what we did, we are traversing in this fashion, in this in this method we were traversing like this, we were traversing like this we were traversing whole matrix, and if we are checking for visited grid, and in this we are just traversing in this manner and swapping the elements, swapping the ij with ji. Okay, we are swapping ij with ji. Okay, they both are swapped, so we are swapping the elements in this fashion. So this is the approach. Now it takes clearly time complexity because we are traversing the matrix, so it takes n square time complexity, and auxiliary space, it clearly takes no extra space, so this is a big of one. Let's code it out. So let's talk about the naive approach. So what I said, let's take one make one visited array, vector of vector int, and this is a visited grid of size n, vector int and 0. Okay, so this much is done. So I have created an n cross n vector, and this is my visited vector, and initially I have initialized all of its elements to be 0. I will run a loop for int I equal to 0, I less than n, I plus plus, for int j equal to 0, j less than n, j plus plus, and what I will do, I will just do a swapping. So I will just swap. So what I will do, I will make one temporary temp to be arr of I j, temp arr of I j. If not visited of I j, and then not visited of I j, okay, this will suffice. And let me exchange the elements. If it is not visited, then temp is equal to this arr of I j equal to arr of I arr of j I, and j I equal to temp. So it's like it's matrix, not it's matrix, not array. Matrix, my bad. Matrix. So this is done. Once it is done, I will mark visited of I j equal to 1 and also visited of j I to be 1. Okay, so this is the thing. Let's try to compile and run. So if you will compile this thing, then okay, temp is not temp. So it will give you the expected output as well, but clearly it will take big of n square extra space. You can clearly see. So this was the naive solution. Let's talk about the efficient solution as well. We have given one matrix, so what I am going to do, I am going to take the n is given the size of the matrix. Suppose n was not given, then what I have done, like I have taken int m to be matrix dot size. It will give me the eventually the size of the matrix, but it's already given, so no need to do this. Now what I will do, I will just for int I equal to 0, I less than n, I plus plus, and I am talking about the efficient approach. And then what I will do, I will go from for int j equal to, from int j equal to I, j less than n, j plus plus, and what I will do, I will just the I will take the matrix, I will swap. So for swapping I can clearly make one driver method. So I will swap matrix ith with jth. Okay, so this would be the approach. And once it is done, I will just return the matrix. Okay, let's create one swap function over here. So we have void swap. I am taking vector of vector int and matrix. Okay, vector of vector int matrix, and I am taking int I and int j, and I am just going to take one temp variable or to be a matrix of I j. I will just put matrix of I j to be matrix of j I and matrix of j I to be temp. It's once it is done, so that's the thing. Let's compile and run. Okay, is there any problem? Return statement with a value, returning void. Okay, it should not return anything, I guess. Transpose and do not return anything. Need to update the original matrix with transpose. Okay, it does not return anything, so just transpose and done. Okay, submit it. Okay, so that was it.